Remember when we did the flame tests in lab and different elements had different colors, like sodium had a yellow flame and there were different colors for different elements. Those are so specific that atomic line spectra or atomic emission spectra can be used to identify elements in an unknown. Now see how we have the full rainbow here on top. The hydrogen spectrum is below it. It has 4 distinct lines. Each line has an associated wavelength and frequency associated with them. Helium has this pattern and neon has this other pattern. So all those lines correspond to a specific wavelength of light. And there's some equations that you need to know. This light has energy, and the energy of that light is equal to h Planck's constant times nu, the frequency of light. It's also equal to h Planck's constant times c divided by the wavelength of light. So each line in the spectrum has a specific wavelength, which corresponds to a specific frequency and energy. So if we know the wavelength of light that comes out or its frequency, we know the energy of the light. And these are characteristic for individual elements. The other thing to notice is that while the rainbow is continuous, there's a continuum. There's light of all colors, which means there's light of all frequencies and wavelengths in the rainbow. However, the emission spectrum of hydrogen or helium or neon have discrete lines. These discrete lines in the spectrum means that there are discrete energies associated with those lines. It's not a continuum. And the Bohr model theorized that these discrete energies, or quanta, corresponded to changes in energy levels in atoms.